Hey everybody, we're going to talk about 9.4 now, okay? And 9.4 actually deals with just solving right triangles. So we're going to use a lot of the tools that we've previously learned to solve types of application problems. So I have a few problems here. If you've already looked on the notes that have been provided, you can see all of the information that we are going to address. So there's quite a few things here to address. I'm going to try to keep it as short and sweet as possible, but still trying to maintain some form of explicit knowledge transferal. So let's get started. I have a problem here called 9.4.3. Okay, and it just says solve the right triangle. So notice what I did here, okay? I redrew the triangle. Ooh, I redrew the triangle, I labeled it, and I noticed that what? Segment RT is congruent to which segment? ST, right? So let me just remind you guys that the segment RT is congruent to ST, right? Because they're both 9 units in length. So that means we have an isosceles right triangle. And if we actually solve it out, then we know that we are now dealing with a 45, 45, 90. And that's the important components to realize. Like keep everything in the back of your head that we've learned, okay? So we now know that the angle is 45. It asks us for the length. So you can see what I did here. Again, I kept the regular triangle, but this time on the other side, I drew, well, that's a weird one. I drew this other triangle, right? And remember, this is our basic 45, 45, 90 with the pattern set in, the ratios set in. So if I take this triangle and move it right over here, boom, you can clearly see that x is equal to 9, right? X is equal to 9. So if we follow our general pattern here, right, then all we have to do is substitute 9 in for x. All of them. And once we do, we can report our answer very quickly. That the distance t in this case is 9 root 2. Okay? So don't forget your patterns for the special right triangles. Okay, and you can see here that I've put everything together, and I even did the calculation out. Okay, so you could see that we were right. Okay, angles of elevation and depression. So we want to elevate. That's what we always want to do. But of course, there are some times that there is depression. So what does that mean? Well, that means from any perspective. Okay, if I'm highlighting this one perspective, this vertex, if you will, this person standing right at that balcony, and they're looking straight out to the horizon. They're looking completely straight out to the horizon. Okay? Then the angle of elevation, so I can call this theta sub e, so angle of elevation, okay, because I'm elevating my head or your head. If you look up, you're going to start elevating your head, right? So that's an elevation. If I go downward now, right, that's an angle, and I'll call it theta of D, depression. Because when you look down, you're looking in a depressed state. You're looking towards the bottom, okay? So we need to understand those pieces of information. Now, what happens if you're not at a specific, like in this case, you can clearly see that this person here, right, is at a particular height. So I want to just draw your attention over to this right here. And that's called the transit. You're going to see maybe some problems with this, and it might ask you for a given height. Now, all you have to do is calculate the way that you would normally do and simply add this height, whatever it may be, to the height of the answer. If you're looking for that, you'll see what I mean when you see the questions, okay? So here we go. One quick question. Oh, and the other thing is just called the sextant. I just figured I'd put that in there because it was nice. It's a way to actually look at angles, measuring angles. Okay. At a certain time of day, this is 9.4.27, the angle of elevation of the sun is 70 degrees. To the nearest foot, find the height of the tree whose shadow is 42 feet long. Okay, well, it gave us a nice picture, and that's great. That helps us out a lot, right? So again, I'm going to just rewrite the original, and I'm going to make the information I have available, right? I know that I have an elevation of 70 degrees, okay? Now, that's not taking in my height, right, or anything. That's literally the ground level. So we're not talking about a transit. Ground level. So this is a very straightforward calculation. So I labeled the degree, and then I labeled the adjacent side like I always have. I've been using orange for adjacent, and I've been using purple for opposite sides. So what I did was, we knew that we have two legs, right? We have two legs, and that's going to deal with tangent, right? Because tangent deals with two legs. The opposite, which is the opposite, which is h, right? So if I drew this in, then this is the opposite to 70 degrees, right? This is the hypotenuse, which we don't really need, and then this would be the adjacent, right? So we have two legs. So that kind of tells us tangent's where it's at, right? So I referenced SOHCAHTOA, TOA, opposite over adjacent. I then input the values that I have in question with the specific variable. I then solved, and the only thing to do here to solve is to realize that I'm dividing by 42, so the opposite is multiply by 42. When I do that, I have my two solutions. I have my exact solution, and I have my approximate solution. And remember, they asked us to record it to the nearest foot. So remember, when you are reporting, report appropriately, okay? Because a decimal place in the wrong spot, if you're doing any kind of micro calculation of a concentration of some kind of serum, if you will, compound, if you will, if you're doing that and you make a decimal point alteration, you could really mess up your final product. So, excuse me. So be very careful and read the directions carefully when it says to round, please. Okay, 9.4.21 says simply find the value for x. I did exactly what I have been doing. I redrew the triangle, right? And I input all the information that I have. Now, given that we're reviewing SOHCAHTOA, well, what sides do we have? Or what parts of the triangle do we have? We have an opposite side to 35, and we have a hypotenuse. That strictly indicates that what we're looking for or looking at is the sine. Why? Because it's opposite over hypotenuse, right? Opposite over hypotenuse. So I did exactly the same thing. We input everything and we solved. And the only thing we had to do was realize that we're dividing by 143. So all we had to do was multiply both sides by 143. And again, I gave you the exact and I gave you the approximate, rounded specifically to the decimal place that they'd like. They specifically said what place? The tenths. See it? So just be very careful, okay, when you're doing those types of problems. Okay. 9.4.29 says that we have a tower, and this tower is 111 feet tall. It's going to cast a shadow that's 113 feet tall. So we are to find the angle of elevation this time to the sun to the nearest degree. Whenever we're asked to find an angle, remember one thing. You are using these little fun trig ratios. And like I said, there's different names that you can call them for whatever reason that works out best for you. If you want to think about it as inverse, that's great. That's a wonderful word. Then that'll help you because of the -1, right? Because that's inverse. If you raise anything to the -1, that always indicates an inverse. You could call it the opposite if you want, because the opposite of the sine is the sine to the -1, for example. Okay? So you can look at it that way, and there's another word, there's a few other words we can use, but the idea here is you could also use arc as well, but we're not there yet, so I don't want to draw that out too much yet. So again, boom, 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 drew the triangle, and then what we are saying here is exactly what I just said beforehand. That we're given legs or sides of a triangle. When you are given sides of a triangle, you're going to use the opposite, the inverse, or the arc of whatever the regular trig function is. In other words, if you are looking at the sine, which is opposite over hypotenuse, you will use sine to the -1, right? The inverse, the opposite, the arc sine. So that way you return an angle. Okay? The regular trig functions are going to help you find sides. The opposites or the inverses, these guys up here, are going to help you find angles. Okay? So I'm just going to make a little note here that this helps you find angles. Okay? So now we know which one to use because we have two legs. That's obviously tan. And if you haven't figured it out yet, just for the record, do you notice what tan is also to be considered? I showed you a little piece about it before. But if you think about the tangent, it's really a slope, just so you know. You see it? Rise over run, opposite over adjacent. Tangent's a very important one for us, okay? So, let's get back to solving the problem. I've now looked, referenced SOHCAHTOA, realized I have opposite and adjacent sides. I have no hypotenuse, so I rule out sine and cosine right away. I've labeled the sides. Opposite is 111, adjacent is 113. I then substituted them into the regular trig ratio. So the tangent of our angle, A, is equal to the opposite, 111, divided by the adjacent, which is 113. Okay? So I wrote it out this way, and I'm hoping that's probably the easiest way to say it for people to remember. If it isn't, please let me know that it doesn't work for you so I can write it in a different manner. I'm trying to simplify things as much as possible, even though they look very complicated. But they're not. Just remember that you're doing opposites. Like the opposite of the positive is the negative. Opposite of multiplication is division. Opposite of the square root is taking the square. So in this case, I took the inverse tan, or tan to the negative 1, of tan A. When I do that, I get just my angle back. And that's the point. So if I do one thing to one side, I've got to do it to the other. So here is the exact solution, which it doesn't ask for, but that's the exact solution. And I've even done the approximation out. Remember, in order to activate the sine to the negative 1, cosine to the negative 1, or tan to the negative 1 on your calculator, you must hit the second button before you hit the trig ratio. It's really, later on you'll find out that they're functions that we have to condense and stuff. Okay. 9.4.35 says a hot air balloon is flying at an altitude of 2,087 feet. If the angle of depression from the pilot in the balloon to the house on the ground below is 29 degrees, how far is the house from the pilot? So notice this time it was completely a word problem. You had to come up with the drawing yourself. So I drew it out. Now, how did I draw it out? Well, I knew I had a right triangle, right? Perfect. So I drew a regular right triangle. That's it. Okay? Regular right triangle. If you want to change your orientation, go right ahead. Whatever works best for you. Okay? But in this case, it makes a lot of sense because the house is on ground level, so it's on the ground, perfectly flat on the ground. We're saying that the ground is completely flat. We know that the balloon's altitude or height is 2,087 feet. And we know the angle of depression. So, the angle of depression, remember, is looking out at the horizon and then swinging down, right? So, this is an angle of depression. Okay? So, in order to get an angle that I could use, drawing out a horizontal and then drawing the angle of depression allows us now to make this definitely a right angle here. And if that's the case, we remember complementary angles, and they add to what? 90. So I took the total, 90, and I subtracted out the 29 to give me the angle in question, which is 61 degrees. Okay? All right? Now, again, reference SOHCAHTOA. We know that we're looking for an opposite side or an adjacent side. Which is it this time? Well, because we're talking about the angle 61, then this right here is the adjacent side. Why? Because this would be the opposite. That's the hypotenuse still, and the adjacent would be right there. Okay? So in this case, we get to use the cosine. And the cosine is a ratio of what? The adjacent to hypotenuse. So again, all we did was we input the information, and then we began to solve. Okay? And I solved for the variable very easily. If you haven't caught on just yet, I'm multiplying by d and I'm dividing by the cosine of 61. So let me just show you the real trick, okay? So here's d, right? I'm going to multiply both sides by d. Then I'm going to divide by not just 61, not just cosine, but the cosine of 61. Do you see now how both of these are equal to each other? Oh, so let me put everything back so we have it all correct, okay? So, when you are putting this into the calculator, you put it in just like that. I got my approximation, and I rounded it to the specific point in question that they wanted, which was the tenths. Okay. Real quick, actually, if you have trouble putting this into the TI, okay, if you have trouble, you simply just want to take the numerator, divide it by, and then make a parentheses. Technically, you really shouldn't have to do this, but it's really playing it safe. Then push the cosine button. Then type in your 61, close both parentheses, and then hit enter. Okay? So if you are having trouble with those, hopefully that will rectify the issue. Okay, the last problem that we're going to work on is a fundamental vector problem that you might see in like a physics course at some point. Okay? We're not going to get into vectors, unfortunately, but we're talking about vectors. They have a magnitude and a direction, okay, for lack of a better explanation at this point. So, smoke is sighted due north of one tower. So, one tower, smoke due north. From Lookout Tower 2, which is 8.7 miles west, so we're going west to the left, right? That's funny, we're going left, right? No, we're going left, correct? So if that's the case, we know our horizontal distance. Okay? A ranger reports the smoke is 44.7 east of due north. Now, you may not have seen that kind of wording before. I'm not sure. So east of due north. What I did was I wrote out the concept here, okay? And what you can see here is that I'm rotating right? I'm rotating from north to east. So I'm rotating north to east. That would be east of north. I know it sounds opposite, but you have to think about it. It's moving from north to east, rotating. So if it's doing that, it's coming from the north, going to the east, therefore it's east of north, okay? If I wanted to say north of east, this would be north of east, okay? So that's the basic concept. What I did was I took that same concept and I drew out our original problem, okay? I color coordinated some things to help out. I hope it helps out a lot. Remember, I kind of labeled the sides as adjacent as orange, opposite as pink, and the hypotenuse as red. I've put in the angle east of due north, okay? That's the 44.7 degrees for you, okay? So all we have to do now, once we have everything, is start to solve the problem. How do you find out the distance, like the smoke is, from here to here? That's what it's asking first. Well, that's easy. Let's do that. Here we go. I drew it all out for you. And what I realized was the opposite and the adjacent had something to do with a piece that we needed, right? We needed that due north. That's opposite of the 45.3. So we used tangent again. We got two legs, right? Opposite over the 8.7. So I just input and then I solved. And how I solved was just multiply both sides by 8.7, and then I recorded the approximate answer to the decimal place that they requested. See how it's getting a little easier? I'm hoping. Okay. And you can see we got it right. Okay. So, same steps. I'm looking at Sokotoa, but this time I want to know the smoke from, like where the smoke is from this tower here. Well, if that's the case, I'm looking for the hypotenuse. So I'm going to look for a side with a value that will help me find the hypotenuse. Well, which is that? Well, it's the cosine, right? Because the cosine deals with the adjacent and the hypotenuse. So, again, I didn't write everything out this time, as you can see, but I just substituted. I then did what? Multiplied both sides by the hypotenuse. And then I divided both sides by the cosine of 45.3, the angle in question that we were talking about, and came up with an approximation of 12.4 miles. Once we do that, we record it, and we got it right. Okay, and as you can see, we're done. All right, I hope this video helped. Place comments, questions in the comment section of the video assignment, please. Thank you, and have a great day.